In our next lesson on linear functions direct variation, we start out right away saying, when a linear equation written in standard form, what's standard form again? What's standard form for a linear equation look like? That's back from some earlier lesson. Jacob?
A plus B equals C.
Not just A plus B equals C, but A x
Alright, A
plus
B
y equals
C.
C. Yeah, so when we talk about standard form, we're really talking about what we already talked about in another lesson. And we said when it's in standard form, it's really handy for finding the intercepts of the linear function. Well, when it's in standard form, then we can also talk about if C is equal to 0, or in other words, 8x plus by is set equal to 0, then it's that special linear relationship called direct variation. And what that really means is that x is varying directly with y. One has an effect on the other, and there's nothing else involved in the relationship. So rather than us writing ax plus by equals 0, typically when we talk about a direct variation, we talk about it having its own form, y equals kx. Because even if it was ax plus by equals 0, when a and b can't be equal to 0, because if a and b were equal to 0, we wouldn't have x's, we wouldn't have y's maybe, and that would create a problem. When we have it in standard form set equal to 0, we can move those x's over to the other side, and those x's would be alone because adding them to 0 would just be that, what you were moving over. Does anybody know what x is called? Or not x, k is called in this situation? What do they call that k value? Jared?
Non-zero constant.
Okay, it's a non-zero constant of
Constant variation.
variation. Yeah, it's called a constant of variation. And you're right, it cannot equal 0. Why can't it equal 0? What would happen if k was equal to 0?
Everything else would be 0.
Not quite everything, but would there be any x's? No, because 0 times x, the x's would be gone. If the x's are gone and we just have y in an equation, say equal to a number, does anybody remember what kind of a line we have when we just have y equal to a number? In other words, when all the y values are the same? Is that a vertical line or a horizontal line? Where all the y's are the same. That's a horizontal line. And a horizontal line cannot be direct variation. Okay. Well, let's just explore a direct variation situation and explore why it would be considered direct variation. If there are 5 people in a room, each wearing a pair of shoes, what would the total number of shoes be? Not pairs of shoes, but what would the total number of shoes be? So there's 5 people in the room. Each of them are wearing a pair of shoes, so how many shoes does each person have? 2. So how could we figure out what the total number would be? 5 times 2. Okay, 5 times 2, how many shoes would there be altogether? 10. Well, what if there were 10 people in the room? How many shoes would there be? 20. What if there were 15 people in the room? 30. Each time, what did we do? Multiply the number of people by 2. Right, because each of them were wearing a pair of shoes. The 2 didn't change, did it? The 2 stayed the same. What changed? Number of people, which then changed the number of shoes. Yeah. So we can say that the total number of shoes in the room varies directly with the what? Yeah, the number of people. So, you want to figure out how many shoes are in the room altogether? In this situation, we would say, oh, just count up how many people there are, multiply by 2, and you have yourselves the total number of shoes in this room, even if we call boots shoes, okay? So, because each time we multiply the number of people by 2 to get the number of shoes. Anybody think they know how we could represent that as an equation then? By the way, are the number of people, are they x, or are the number of shoes x? And which of those is the y, the number of people or the number of shoes? Okay, so which is the x? Number of people. Okay, so this is really, the number of people is really our x value, and then the number of shoes is really our y value. So how do you think we could represent that as an equation? Abby?
Y equals 2x.
Y equals the number of shoes is equal to 2 times the number of people. Y equals 2x. So what's our constant of variation? 2. That never changes. The only thing that changes are the number of people, which then changes the number of shoes. So the number of shoes varies directly as the number of people in the room. It is the only thing affecting it. Okay, well what if there were 2 extra pairs of shoes sitting in the closet? So I have a couple closets here. What if I'm keeping a couple of extra pairs of shoes at school? I have a couple of pairs of shoes in my closets back here. Would this still be a direct variation then?
No.
How many people do we have in here today, including me? 16 of us. So how many shoes should be in this room if I don't have any in the closet? 32. Okay, so there should be 32 shoes in this room if I don't have any extra around. I don't have any in the closet or anywhere. Okay, well what if I do have those 2 pairs of shoes? How many shoes would I have extra? 4. Okay, so would this still be direct variation then?
No.
Why not?
Because no one's wearing those.
Because no one's wearing them? Only because no one's wearing them?
Well,
Okay.
2 doesn't change, just the amount of shoes in the room.
Okay, so we don't multiply that 4 by 2, do we? It's kind of like we start with those 4 and then we add to it 2 shoes, I mean, for every person who's in this room. Okay, so that 4, that extra 4 shoes makes it from being, it can't any longer be considered a direct variation. Now we cannot just multiply by how many people are in this room and say, oh, okay, this is how many shoes there are, because we have those extra 4, don't we? And so we are going to say that this would actually be, now what would our equation look like? Y equals, what would the equation be?
2x.
Chair?
2x plus
2x plus 4. Take the number of people, multiply by 2, add those extra 4 shoes that are in the closet, and then you'll get the number of shoes that are in the room. So this is not a direct variation anymore. And what part of this makes it not a direct variation? Abby?
4. Adding 4.
Yeah, the plus 4. This right here. Because remember, what does the C value have to be in a direct variation? Could we rewrite this in standard form? Let's rewrite this in standard form. What would it look like rewritten in standard form? So let's put it in standard form. What would that look like? X's and Y's have to be together on the same side, and the constant on the other side. So what would it look like? Any ideas? Really? You can't put this in standard form for me? What's the problem? Jacob?
2x plus negative y equals 4.
2x plus negative y equals 4. Okay. 2x plus negative y equals 4. Or in other words, 2x minus y, same thing, right? Okay. So now it's in standard form. When it's in standard form and it's direct variation, what has to be true? What has to be true for it to be direct variation? Go look up above in your notes. What does it say up there?
It needs to have a constant
It has to have a constant of what?
variation.
Well, okay, well,
Constant change.
there is a constant change going on here. There really is a constant change going on. It's still 2. But it's just not, considered a constant of variation because there's something else going on. So you guys have to recognize that this right here, what does this have to be equal to? What does that have to be equal to? Okay, let's go back up here. Look at here. It says, zero. That has to be equal to 0. When it's not equal to 0, remember it said right here, when a linear equation written in standard form has c equals 0, then we can say it's direct variation. Well, once we took our equation that we said probably isn't direct variation and put it in standard form, it was not equal to 0. It proves, no, this is not direct variation. So the number of shoes in the room does not vary directly as the number of people, because we can't just multiply how many people there are by 2 and we'll know how many shoes are in here, because there's those extra 4 that we have to add. Do we add those 4 for every person that comes in? No, we only add them one time. Okay. So let's go to the back side and let's work on how do we identify direct variation when we don't have any idea what the situation is about. We have this table of ordered pairs. How are we going to decide if it's a direct variation or not? We don't want to graph it. If we did graph it, how could we tell from the graph? Anybody know that? Yes? Have you figured that out from your SQ3R? Not yet, okay. Well, one way to do it, method 1, is write an equation to model the ordered pairs. Do you guys know how to do that? Have you learned how to write an equation to model ordered pairs? Uh-huh. You look for the rule, what's going on in that table. So table A, what's the rule? What's going on? To get from 2 to 6, 4 to 12, 5 to 15, 8 to 24, what's the relationship going on there, Braden?
X is being multiplied by 3.
Yeah, X is being multiplied, and we're just going to, we got to keep these separate, so we're going to keep room here too, okay? X is being multiplied by 3. So what would the equation be then?
Y equals 3x.
Y equals 3x. So what do you think? How are you feeling about this? Do you think it's a direct variation? Is there a number being added to those x's when y is alone? No. If there's not a number being added to those x's when y alone, that means the constant was 0. So we don't have any, we have a constant of 0 like we're supposed to have, so we would say, yes, this is direct variation. So we're determining if it represents a direct variation, we would say yes. And if it is, we're going to say, what does k equal then?
K equals 3.
K equals 3. Which in method 2, I think we're going to discover that's what we're going to find. Because in method 2, we're just going to stay with this table for right now. It says find y over x for each ordered pair. So take the y value from the ordered pair, put it over x, and find out what that ratio is. So what's our first one in the table?
6 over 2.
6 over 2. And 6 over 2 equals 3. So it's kind of like we got to pretend we didn't look for the rule yet. All we're doing is saying, okay, if I put 6 over 2, what do I get? I get 3. What's the next one?
12 over 4.
12 over 4. If I put 12 over 4, what do I get? 3. Now you got to be really careful. You got to make sure this holds true all the way through the table. You don't stop and say, oh, I got 3 twice. Good enough. So what's the next one? 15 over 5. And what does that equal? 3. And our last one?
24 over 8.
24 over 8. And that's 3, isn't it? Okay, so if when you set up all the y over x relationships, you get the same constant, you are actually finding the constant of variation. So if you use this method, you can say yes. And again, you can say, because I got 3 every time, so the constant of variation must be 3. So y over x, just like in slope, the y is upstairs, the x is downstairs. Any questions about that one? Let's go to the other table. Anybody see a relationship going on here? Courtney?
X is subtracting 3 to get y.
So subtract 3 from x. We don't have to do anything else, just subtract 3 from x, and we get y every time, okay? So what would our equation be?
Y equals x minus 3.
Y equals x, take away 3, okay? We get our y by subtracting 3 from x. So is this a direct variation? Why not?
Because
We're subtracting what every time? 3. And so in other words, can there be a constant thing? What, in other words, is the constant in this problem actually 0 like it's supposed to be? No, what is it?
It's 3.
It's negative 3, really. Yeah, it's like it's negative 3. So we have to say no to this one. And in this case, we would say because C is equal to. Well, in this case, I'm wrong when I said it before the other way. When you said 3 and I said no, it's negative 3. We got to put it in standard form first. So if we put those x's, if we move the y's over with the x's and the 3 over to the other side, we could say C is equal to 3. So in reality, we can move the x over with the y and say that C is negative 3, or we can move the x's over, or the y's over with the x and 3, and move that 3 over and it'll be positive 3. Regardless, what does C have to be? Whether it's 3 or negative 3, it has to be 0 to be considered a direct variation. Well, hopefully that would tell us then that when we do our y over x relationship here, should we end up with a constant of variation? What do you think? Okay, so what are our relationships we can set up?
5 over 8.
5 over 8.
7 or 4 over 7.
Okay, 4 over 7. We might want to change these to decimals just to compare them. What's 5 over 8 as a decimal? No one knows that one by heart?
0.625.
Yes, 0.625. What is 4 divided by 7?
0.9714.
Okay, so we're going to say approximately. We have to round that one, don't we? So let's say approximately 57 hundredths. Can we stop right there?
Yep.
Yeah, because what have we just proved?
Not constant.
Yeah, there is no constant of variation. So let's put that in our notes. That's how we would say it. We'd show it already broke down, so we would say there is not a constant of variation. In other words, we would not be able to identify a k value. So you can use one method or the other, whichever one you think will work better for you. So questions on that one at all? So in a direct variation, what does the capital C, the constant in the equation, not the constant of variation, you gotta be able to keep these straight. Constant of variation is a multiplier. Capital C, big C, the constant in the equation is just a number. It's not a multiplier. It's being added or it's being subtracted. So what has to be true? Big C has to be what again? 0. And if C is 0, then we can determine what little k is. We can figure out what that constant of variation is, because then it is a direct variation equation. Okay, well sometimes they're going to say to you, I want you to write and solve a direct variation equation, and they're just going to give you some information. If y varies directly with x, in other words, they're telling you y does vary directly with x. They have a direct variation relationship. And you were given at least one ordered pair for the relationship. In other words, you know already it's a direct variation. They give you an ordered pair. What can you do with that ordered pair to help you find the constant of variation? What did we just do? We put y over x. And then after we know what k is, can we write an equation? Sure we can, just like the shoe situation. When k was equal to 2, were we able to write an equation? Yeah. So here we are, we're given that y is 4.5 when x is 5.5. It's kind of like saying we have ordered pairs 0.5, 4.5. They're giving us an ordered pair from a direct variation relationship. They're saying it is a direct variation relationship. They want you to find y when x equals 10. So what we're going to do is we're going to put the y value over the x value and find our k value. Because any y over x from a direct variation should give you your k. So how many halves are there in 4 1/2? 9. So k equals 9. Okay, so what would our equation be for this relationship? Remember, a direct variation relationship is this: y equals kx. We know k. So what's our equation? Yeah, y equals 9x. So our equation is y equals 9x. Well, the next thing we're supposed to do is we're supposed to find y when x equals 10. So what do you suppose we can do with our equation?
Subtract, replace x with 10.
Yeah, replace x with 10 and get
90.
y. So y equals 9 times 10, y equals 90. So if we're told it's a direct variation relationship when they say if y varies directly as x, they're telling us right there it's a direct variation. Once we know it's a direct variation, we can count on that there's going to be a constant of variation. If there's going to be a constant of variation, we can get that by taking any ordered pair and putting the y over the x and dividing it out, and that'll give us our k value. Once we know our k value, we can put it into our model for a direct variation equation, which is y equals kx. And then once we have that equation, we should be able to find any other ordered pair on that line if we know either the x or the y. We should be able to find that other missing piece of information to help us get the other part of the ordered pair. Now, just as a quick summary of this, can anybody tell me what's going to hold true? What did you not learn something about all direct variation, linear relationships on a graph? Abby?
Through a straight line.
They're straight line. What else? That's the linear part. What makes them direct variation? What happens on the graph? Because C, big C is equal to 0, where does the line always cross through? The origin. Yes, it will always cross through the origin. So if you have a line crossing through the origin, you can count on that it is a direct variation relationship. Okay, any questions? Okay, then let's get you going on your homework.